Okay, so this 3.6, as it says, quantitative information from balanced equations. That's just sort of a fancy way of saying that we're going to do math with the information from balanced equations and get numbers and stuff from it. Okay. The coefficients in a balanced chemical equation indicate, number one, the relative numbers of molecules or formula units in the reactions. Okay, so like we've got 2 H2 gas plus O2 gas yields 2 H2O liquid. The 2, 1, and 2 represent 2 molecules of hydrogen, 1 molecule of oxygen, 2 molecules of water, right? Like that's relatively, everybody knows that. The second one is the relative numbers of moles. And this is the thing, I think I put it up in this, I should have put up in the scan from the notes from last week. Do you guys know, did I put up a scan of the notes? Like with the information on them, or just the blank one?
I think it's the blank one.
Okay, so let's see if I have it here. Oh yeah, I just put the blank ones, and then but I did this information in the videos. That's what it was. Okay, so hopefully you watch the videos, and this information from the video where the subscript tells you the number of moles. So it's like this. We've got this, right, which is the element, the number of moles of the element compared to the moles of the compound. So this is the element within the compound, right? Now, this is a separate idea. And this is why I showed you that, because I don't want people getting confused. But this is a separate idea, but similar. And that is the coefficients in here are also relative number of moles. So you can say we have 2 molecules of H2, 1 molecule of O2, 2 molecules of H2O. You can also say that for every 2 moles of H2 and 1 mole of O2 that react, 2 moles of H2O are produced. So there's 2 ways that we can kind of use mole comparisons and conversions. All right. So this symbol, and there is no symbol in the thing to put in there, so it looks like this, means is stoichiometrically equivalent to. So I'm not 100% sure, but I think it's very similar to in math. You guys have this little dealie, which it's not an equal sign. It means like, yeah, it means like approximately equal to or whatever, right? I think. So I think that this is similar in chemistry. It just means that they are, like, comparison-wise, equal or equivalent or ratios of each other. Okay. So the best way to just go through this is just to do the problem. So we have, and we did some of this in Chem. We did this in Chem 1. Okay, it's just a matter of kind of like digging back and getting to it. So when 1.57 moles of O2 reacts with H2 to form H2O, how many moles of H2 are consumed in the process? All right, so what do we have? We've got moles of O2, and we've got the question, how many moles of H2? Right, so because it's a different substance, that means we have to convert from moles of one substance to moles of another. All right, in this case, we're already in moles, so we just start off with 1.57 moles of O2. Okay, label on the top goes on the bottom, so moles of O2 on the bottom. And we can go, the way we change substances, if you recall, hopefully, is moles to moles. So moles of that to moles of the other substance. We want to go into H2. All right. Now, anybody know where we get the numbers in the front here? The mole to mole conversion? Yeah, close. the coefficients on this one. Okay, how do we know if we're looking in the subscripts or if we're looking in the coefficients? Here's how. If we're going from a compound to a single element in that compound, we use the subscripts that are in the compound itself. If we're going from one substance to a different substance, we use coefficients from the balanced equation. All right, so in front of O2, up here we have nothing, so it's a 1. In front of H2, we have a 2. So it's just like this. And it says how many moles of H2, so we're in the label we want to be in, so we just do the math. Significant figures, 3, so it's 3.14 moles of H2. Boom. All right. Make sense? All right, let's do the next example here. Calculate the mass of CO2 produced when 1 gram of C4H10 is burned according to the following equation. They give us a balanced equation here. All right, so I start off with the 1 gram C4H10. Okay. And I'm trying to get this into mass of CO2, right? So what label are we going to use for mass? Grams, good. Okay, so I've got grams of C4H10, and I'm going to grams of CO2. Remember, if you're switching substances, the only way you can change from one substance to another is to get them into moles. Okay, so I need to go from grams C4H10, and I need to convert this into moles of C4H10. I can't change my substance yet because I'm not in moles yet. So C4H10, this is the adding up 4 times the carbon, 10 times the hydrogen, add them together, you get 58. Okay. Then, okay, now moles up here, so moles of C4H10 on the bottom. And what should I be trying to turn this into? Yeah, good, moles of CO2. All right. So what number is going to go in front of my moles of CO2? 8, good. And what in front of the C4H10? Good. From the coefficients, right? Okay, now I'm in moles of CO2. I need to get it into mass, which we already said was grams, correct? So one more step here. We're going to go from moles of CO2 to grams of CO2. Remember, that's the formula mass. Okay, now I'm in grams of CO2. Everything else is canceled. I just do the math. Multiply and divide. Significant figures, you started with 3, so our answer needs 3, so it's 3.03 grams CO2. All right, how are we feeling so far? Are there any questions or anything that is thrown you guys? All right, last one. Okay. How many grams of water are produced in the oxidation of 1 gram of glucose? All right, so this is the same type of thing, right? So we're going to start with the gram glucose. Okay. What label goes on the bottom of our next step? Grams of glucose, right? And what am I turning that into? Good, moles. Okay, so the formula mass of this is 180. Okay. Next step, what goes on the bottom? Moles of glucose, good. And what am I turning it into? Say it again. Good. Moles of H2O. Because we're looking for grams of water, right? So we need to get into moles of water first. All right. Number in front of the H2O is what? 6. Good. In front of the glucose? So 1. Excellent. Okay. Next step. Label on the bottom is what? Moles of H2O. Excellent. And we want to turn it into what label on the top? There we go. Moles. Grams of H2O is 18. Okay, and we're in what we're at, or we are in what we want, so we just do the math. And this kicks us out. Significant figures are 3, so it's 0.600 grams of agua. That could be a problem. Okay. How do we feel?
Pretty good.
Good. All right.